Hey guys, in this video we're going to look at factoring trinomials. We're going to see, and trinomials are the ones with three terms, hence the name. And we're going to see two of the three styles that we're going to encounter. So returning to the kind of the flow chart, once we've gotten our GCF out, then we're counting our terms. We saw the four-term ones, the grouping ones in the last section. So now we're in the three terms, and we're doing A and C this time. So these are the ones where the leading coefficient is a 1, so that means it's something like this with a plain x squared. And then this next kind we're not going to see till the next section, but the next question we would ask is there perfect squares on the ends for this section? That's a no. And then that would leave us with the magic method for our other version of solving. So for here we're going to see leads with the 1. This doesn't fit yet, or this other kind that ends up being kind of the hardest of the factoring methods. So let me show you some example of these. And like I said last time, factoring is really the reverse of multiplication. And so you'll see when I do this, it's going to look a lot like a FOIL. And so I'm going to do is I'm just going to run through this first one, factoring, and then I'm going to show how it connects to FOIL at the end. So for the kind where it's a 1x squared, a little invisible 1 right there, we want to ask what multiplies to this end number and adds to the middle number. And so with 35, we always want to do the multiply first and then see, because that's not so many choices, and then see which of those adds to 12. So if I think of 35 and the possible things that it can multiply to, it would be 1 and 35, and then 5 and 7, and that's it. Those are my only two choices for 35. And so 1 and 35 adds to 36, 5 and 7, those would add to 12, which is what we need. So it multiplies to 35 and then adds to 12. So that's going to be our factors. And then the way we write the answer is x plus 5 and x plus 7. So this does look like those FOIL problems. For factoring, this is the answer. I'm just going to show the FOIL on this to kind of show how factoring and FOIL are connected on just this one example. This is also, if you ever want to check a factoring problem, this is what you would do, is you just FOIL it right back, and you should get right back to where you started. So if I do my FOIL as kind of a check, or just to explain, I get x times x, so that's x squared. And that's why we have to lead with these x's, is because that first term is going to give us x squared. And then if I do the outside, I get plus 7x, and then I do the inside, I get plus 5x. So that's why our two numbers have to add to be the 12, because if you look in this, that's exactly what ends up happening, is they add to be that 12. And then 5 times 7, so there's the 35. So that's why these two numbers have to multiply to be 35, is because that's where that shows up on the end. And you can see if I collect terms, I'm right back at the 12. So for this whole thing, it multiplies to the end, and then of those choices, what adds to the middle. So for number 2, this is where we start kind of encountering the different possibilities of signs. And so I think I have all four kind of combinations here. This one was positive, positive, and those are easy. If it multiplies to a positive and adds to a positive, you got two positives. So that's what these signs are going to do. Here I have two things that are going to multiply to a positive, but they're going to add to a negative. So that means they both have to be negatives, right? Because two negatives multiply to a positive, but can add to a negative. So if I think of 30, I can run through, 1 and 30, 2 and 15, and then, okay, those two add to 17. If that hadn't worked, I would have just kept going down the list, and eventually I'll hit it. So the better you are with your times tables, the easier these are. So this is going to go x and x. And then it's going to have to be a negative 2 and a negative 5 to multiply to 30, add to be negative 17. Sorry, I think I said 5, but 15 I should have said. For this one, so now they're multiplying to a negative. So to do that, we'd have to have mixed signs. So if I'm thinking about how I'm going to come set this up, it's going to have to go plus and minus, because to get a negative 28, one has to be positive, one has to be negative. So then that means that, and then the middle, they still have to add to be 12. So if I think of 28, so I got 1 and 28, I got 2 and 14, 3 doesn't work, I got 4 and 7, and after that I'm not going to hit anything new, because 5 and 6 aren't going to work, and I'll be back at 7. So if you look at that, none of those add actually to be 12. And the reason is it's that plus minus. So when you're dealing with one where it's a negative, it is better to think of it as the space between the numbers. Let me say that again. So we're looking for the space between these two numbers, not the addition of it. It's still adding, it's just one of them's negative. It's hard to think about it that way. But if I look at 12 as how far between, this is 27 between the numbers, this is 12 between the numbers, that's 3 between the numbers. So that's going to be the one we're looking for. It is still addition, it just means the 2 has to be negative and the 14 is positive, because negative 2 plus 14 does make 12. But if you think of it as a space between rather than the sum, it'll make it easier to find. Also, because this number was positive, that tells me the big number has to be positive. So the 14, because it's going to win when we add them. So 14 goes there, 2 goes there. I could have written these in either order, doesn't matter a bit, just kind of the order I happen to write them down. This next one, we got another 30, and so this time it's going to multiply to be 30 and then be negative 1 when we add them. So if I think of 30, and I want two numbers that multiply to 30, and now I'm thinking of them as 1 apart, then it makes it easier, hopefully, to see the 5 and the 6. And since the middle term is negative, the big number is going to be negative, because the middle takes the sign of the big number. So now I got x minus 6 and x plus 5. Again, these next 4 I'll go through a little bit more quickly. These are the matched examples that I'd have you guys try in class. So we got x, because we know we're going to get that. I need multiply to 24 and then add to be 11. So if I kind of think of my numbers, 1 and 24 way too far apart. 3 and 8 should work. So if I do 3 and 8, and I could have done 2 and 12, too far apart, 3 and 8, and you hit it. So it's just looking down the list of the possibilities and just keep looking, because it'll be there. And then we get plus 3 and plus 8, and that'll be it. Number 6 multiplies to a positive, adds to a negative, so I know I'm going to have both of these are going to have to be negative to get that positive there. 60 can be a little bit hard to see. Again, if you can't see where to go, start the list. 1 and 60, 2 and 30, 3 and 20. You can see I'm getting closer. That's 23 now. I need 19. If I go 4 and 15, there's my 19. So if you can see that 4 and 15 right off the bat, there's no reason to do all that. But if it's a harder number and you can't quite spot it, just make the list and you're going to find it eventually. So 4 and 15, we're done. For this one, I need them to multiply to be negative 32, and my number's going to have to be 4 apart, because that's a negative. So then 8 and 4 multiply to 32, they're 4 apart. The middle term is positive, so that 4 is going to be my negative, because 8 plus the negative 4, 8 minus 4 makes 4. So that's going to be x plus 8 and x minus 4. Number 8, we need them to multiply to be 70, and we need them to be 3 apart. So then 10 and 7 jump out a little bit more if you think of them as the 3 apart. Middle term is negative, so big number's negative. And I got x minus 10 and x plus 7. So this next round is the same thing, but just with a little bit extra going on that we got to sort out. So if I look at this one, it does not look like the problems I just did. And none of the 8 we just did had a GCF. And so now we have to start kind of being on the lookout for GCFs. So this one, I got 3, 12, and 63. So 3 is my least interesting number. So then it goes into the others. That's going to be my numerical piece. X cubed, x squared, x. So remember, when you take out the smallest power in x, that brings an x out front. And now when I rewrite this inside, I get x squared. 3 goes into 12, that'll be 4x. 3 goes into 63 21 times, so minus 21. And now if you look at this piece, that looks like all the ones we just did. And that's going to be a very common thing to happen, where if you miss the GCF, you can't tell from here that it's really just a fairly friendly one of these type, where we just do our parentheses and figure out what multiplies to 21, adds to be 4. But absolutely critical you get that out of your way. So 21, and we need them to be 4 apart, so it's going to be a positive 7 and a negative 3. 4 apart gets me positive 4. And so once we get out of that last section with GCFs, almost every problem that we encounter, when we get the GCF out, this piece is going to factor further. If you're taking my exam, I would not waste a question on just a GCF. I promise this piece is going to factor further, so make sure to look for that on the exam. Yeah, so that pretty much wraps that one up. This one is, again, just kind of the same deal, except it has that r squared on the end that freaks people out. So for a second, I'm just going to pretend like it's not there. and just ask what multiplies to be that 54 and adds to be negative 15. So if I think of a positive 54 and I need add to 15, sounds like 9 and 6 add to 15. And then they're both going to have to be negatives to get a positive 54 and the negative 15. So what we do then is, you know how we set the x's up in the front, the r squared, we're just going to set up r's in the back, and then that's going to get us that r squared back. And I'll do a little FOIL to show how that xr comes back into play at the end. So minus 9r there, minus 6r. And so you can kind of see x times x, there's our x squared, 9r, 6r, that's going to get us 54r squared. But if you look at the cross terms, you would have a x times the minus 6r, which would be minus 6xr. And then on the inside, you'd get another minus rx, write it as xr, since I just wrote this one that way. And you can see that's how we get the x's and r's in the middle. So you don't really need to overthink all that. Just think, okay, if I got x squared up front, I need x's in front. If I have this r squared behind, then I'm going to need r's at this end to get the r squared. The next two are just, again, the matched problems I would have students try in class. So for this one, 6, 42, and 36, so it looks like we can get a 6 out of there. And that's going to leave me an x squared, a plus 7x, and a plus 6. So I need two numbers to multiply to be 6 and add to be 7. So it sounds like x plus 1 and x plus 6 would multiply to 6, add to 7. That one, definitely a GCF going on. So that's going to go, we can get a 5 out of everything and an x squared. So that's right here going to leave me an x squared. 5 goes into that, I think it's 13, yeah. And then 5 goes into 240 times. And then again, don't stop here, especially on the test, because that won't be where it ends. So this is going to go x. I need it to multiply to 40 and add to negative 13. So we have two negatives, and it'd be 5 and 8. Okay, another GCF, and this one's actually pretty similar to the one I did. Oh well. X squared comes out, x to the second minus 15x plus 54. And then that 54, I just ran into that one. It's probably, oh well. 6 times 9 again, and so 6 times 9 makes 54, 6 plus 9 makes the 15. So we'll have an x squared, an x minus 6, and x minus 9. And then this last one for the matched. So no GCF, so I can just set it up with x's in front. And then it's got the r squared there, so I'm going to have r's in back. And I just need to figure out what multiplies to negative 90, and then that is an invisible 1 there. So it looks like it'd be a 10 and a negative 9 would make negative 90 and add to 1. So plus 10 and minus 9. Okay, so now we hit kind of the second half of the section, and this is probably the hardest of the factoring methods. And there's a few different ways to do this. If you learned guess and check in high school and you're used to setting up 5x and x and doing the parentheses and then trying 1 and 8 and 2 and 4 and then 4 and 2 and 1 and 8 again, or 8 and 1, that is the worst possible way to solve these. Like, let that go, stop doing that now. What I'm going to show you is much better. There's also a method called AC method. It's my kind of runner-up. I'm going to stick to magic method, the one that I like better. But there are other ways to do this. If you have something that works really well for you already, do not feel like you need to switch out to my method, because there's definitely more than one way to get these done. Unless your method is guess and check, in which case your method is terrible, it's awful, and you need a better one, and so then you should definitely learn this one. But if you already know AC and you're solid on it, that's cool. Just do it that way, and that will totally get these ones taken care of for you. So for me, I do magic method. It's a little funky, but it has some places where I think it makes things easier in terms of the keeping track of where you are. So it's the one I like best. What we do is we go the first thing times the last thing. And that's the A times C that the AC method uses also. So 5 times 8, and I get 40. And now it's kind of like the last problems I just did. We're saying what multiplies to be 40 and adds to be 22. Okay, so that one would be 20 and 2 multiply to 40, add to be 22. So then here's where this gets a little bit kind of weird. I'm going to go 5x up front, and then I'm going to do another 5x, and one of those 5s isn't real. One of those is going to divide out before I even get down to my next line, but what I'm doing is I'm just setting it up with the 5s with the intent that I'm going to cancel out one of those. And so if you've ever done guess and check method, the whole thing is you have to get everything plugged in the right spot. With this, we don't. It's going to reduce and just everything's going to work out. So then after I do that kind of extra 5 in there, I just toss my 20 and my 2 in. And then I go, okay, where can I divide out the extra 5? If I divide it here, it's a mess. I get a fraction, but if I divide it here, it comes out very nicely. And so now I just reduce the 5 right back out of the problem. And so that would be, and this 5 belongs to the 5 and the 20, so you have to reduce with both. So 5 into 5 would leave x, 5 into 20 would leave a 4, and then 5x plus 2, and that's it, you're done. So it's a pretty reasonable method for getting through these. Again, if you have something that works for you already that isn't guess and check, because that one sucks, go ahead and do that. But if you don't have a method, this is a pretty good one. Let me do another one of those, and then there's a couple of matched ones here. So this one, right now, if I went 14 times 4, that is 7 times 8, I'd have 56. And that's kind of a bigger number to work with. And that would not be a good first step. And the reason is, if you look, everything is even, right? And I would be working on this 56. At the end of the problem, I would still have a greatest common factor in one of the factors I'd have to get out. And so that would be a really, really hard direction to do the problem. So what you really want to do is on every one of these, stop, look at it, and go, there's a little 2 hiding in there, and get that GCF out of your way, and it will make this way easier. It's really hard to come back off of missing the GCF and still end up getting it right. You can, but most people don't kind of recover on that last step. So if you get the GCF out first, now all of a sudden, instead of 56, now I get to go 7 times negative 2, because this piece is done. It's just going to come along for the ride the rest of the way. So this is the only piece I'm actively working on. So now I get to go 7 times 2 and get negative 14, which is a much easier number than the 56. What multiplies to be negative 14 adds to be 13 would be a 14 and a negative 1. And then I just do the thing where I throw the 7x down, toss my 14, throw another 7x down, knowing that one of those is going to reduce out, because you're always going to be able to reduce whatever that fake number, that number in front of the x squared, actually not there, sorry, after you've done the GCF. So that number in front of the x squared, that's always going to simplify out of the problem. So I can do my 7 right here because it goes into both. And sometimes it's going to do just one side or the other. Sometimes you may need both sides. We'll see that as we go on. But that's the 7 I needed. So then we got x plus 2 and 7x minus 1. And then the next 2 are the ones I would have you try in class. So the first one, we're going to go 5 times negative 3 and get negative 15. So that's our A times C. And then ask what multiplies to be this and adds to be that. So it looks like I'd have to go negative 5 and positive 3 would get me the negative 15 and add to be that 2. So then down here, I'm just going to go 5x, and then toss these in. And again, on one of them, or sometimes both, but for this one, 5 is a prime, so it can only go to one or the other. So someplace that 5 is going to divide, and that's going to be right here this time. And then that's going to go x minus 1 and 5x plus 3. 18, looks like we can get a 3 out of there. So that's going to leave me a 5x squared right there, a plus 8x. And 3 into 13 would be, 3 into 39 would be 13. And so now we're going to go 5 times negative 13, and that's going to give us negative 65. And then what multiplies to be negative 65 and adds to be 8 is the same 13 and 5, right, that I was just working with. This time it'll have to be a positive 13 and a negative 5 to get the positive 8 in the middle. So then I just, again, carry down with that 3 and then just set up your parentheses, 5x, and we'll throw in our minus 5 and our plus 13. And then right there, that 5 is going to divide out, so we'll just get rid of that. And 3x minus 1, careful not to poof that, and then 5x plus 13. So these two are just showing, we get that extra letter in there again, how that would look. And then this one is to give you some strategies on what to do when the numbers really, really suck. So over here, there is no GCF, so I'm just going 3 times 4 makes 12. And then what multiplies to positive 12 and adds to be negative 8 would be a negative 2 and a negative 6. So down here, I'm going to go 3x, and then the same as I did on the problems with the extra letter before, I'm just going to throw my y's on the end, and then that's going to get that y squared back, and then a minus 2 and a minus 6. And now I got a fake 3 floating around, so I got to look to see where I can divide that, and it's going to be right there. And then 3x minus 2y, and 3 goes into 3 once, so I'll just leave the x. 3 goes into 6 twice, so that will leave a 2y. So this one, 20 times negative 30 would be negative 600, which is a giant number and has lots and lots of things that go into it. So I'm not going to quite do that. I'm going to use this for my scratch work. So I'm going to think of 20 and 30. And I'm going to think of some numbers that maybe make 20 and maybe make 30. And I'm going to try to kind of regroup those and wiggle them around until I can find maybe a pair that's 1 apart. Because they're multiplying to it's a negative 600 again. And you could make this list. It would turn out it would be the very last one on the list, which would be sad. So we're going to try to do a little bit smarter down here. So I'm just going to think I need to multiply to 600, which 20 times 30 does. So anything that I factor these down to will also multiply to be that 600. But I'm going to see if doing that, I can maybe spot a way to get 2 numbers that are 1 apart that's easier than going through all the factors of 600. So for starters, I'm just going to, try something basically. So I'm going to go 4 times 5 for my 20, and I'm going to go 5 times 6 for the 30, and just see what that gets me. If I kind of wiggle these numbers around a little bit, I can see a 25 right there. So if I think of this as 4 times 5 times 5 times 6, if I put those two together, because that is still, again, that's 600, that would be a 25. And then these ones over here, if I put those ones together, that would be a 24. And there's my 2 numbers that are 1 apart. So that was a lot easier than making the big list. Sometimes it's harder to spot than with those. Sometimes it's just that easy. But it's generally going to be better than running down all the possible factors of 600. So coming back here, I'm going to have a 20x, and then which one? My 25 is going to be positive because it's a plus 1. And then I'm going to have that other 20x, and then that's going to be my minus 24. And so I'm going to need to divide out 20 because one of these is not real. And what you want to do is just look and see what's the biggest thing you can divide into the factors, because now 20 can be split up. Everything we've done so far was prime, but 20 could be 2 and 10, 4 and 5, 1 and 20. So there's some options on this one. So looking at 20 and 25, best I could do there is a 5. Looking at 20 and 24, best I could do there is a 4. And if you look, 4 times 5, that's that 20 that needs to reduce. So it's all good. It's just happening on 2 pieces this time. And then to finish that out, 5 goes into 24x, 5 goes in 25, 5. 4 goes in 5 times, and 4 goes in 6 times. So that's a pretty hard problem, but if you kind of use this little trick, that can make it a lot easier to find those 2 numbers. And then these last 4 are all just matched problems that I would have you guys try in class. So 6 times negative 3 is going to make a negative 18. And we need 2 numbers to multiply to negative 18, add to be negative 7, so it sounds like negative 9 and positive 2. So this is going to go 6x minus 9, and this time we got that y, so I'm going to do the y on the end. And then our other 6x plus 2, and then with the y on the end. So there's our, so this time we got a 6, and it's going to break up in kind of 2 places. Over here, the best I could do is a 3. Over here, the best I could do is a 2. So then when I reduce that out, 3 into 6 goes 2x, 3 into 9 goes 3y, 2 into 6 goes 3x, and then 2 into 2 would be 1, and so just plus y. The next one, so yeah, this is a great example of why it would really suck to miss the GCF. If you went 21 times 77, I don't know what that is, but it's really big. There is that this and this are clearly divisible by 7, makes me really want to hope that that one is also divisible by 7. And so if you try it, you can get the 7 out of the 21, and that's going to leave you a 3x squared. 7 goes into 98 14 times. And then 7 goes into 77 11 times. So you can see this would have been an awful problem if you missed the GCF. And plus, you wouldn't have probably caught it at the end because almost no one does. And then it would have been wrong. And so instead of whatever 21 times 77 is, now we get to work with 3 times 11 or 33. And that's a much better spot than where we were without that GCF. So now I can just do my 3x, multiplies to 33, adds to be 14. It's just the 3 and the 11 again. So I can do plus 3 and plus 11. And then that extra 3 is going to divide right there. That's going to leave me 7, x plus 1, and then that 3x plus 11. Next one, another GCF, another 7. So again, 7x squared, because that's our smallest power. And then this is going to go, oh, I'm sorry, that's totally not true. I was anticipating that 52 working, and nope, I totally fell for it. My bad. How about x squared? So we actually have 7x squared, and then minus 52x, and then plus 21. Oops. Okay, so we got the x squared out of the way, and so we do kind of have terrible numbers this time. But I'm going to use that trick I did on the last one. So we have a 7 and we have a 21. And the only thing 21 can do is either be 21 and 1 or 7 and 3. So if I break that 21 down, it becomes much easier to see that with the 7 over here, I could do 49 and then times 3, and that's going to get me to that negative 52. So x squared, I'm going to have a 7x. They're both negatives because they multiply to a positive and add to a negative. So minus 49 and then 7x minus 3. And then right here I can get the 7 out of there. That's going to give me x minus 7 and then 7x minus 3. And then this last one looks like there is a 2 and an r in every term. So we'll get that pulled out front. That's going to leave me 10x squared plus 7x. And then that'll be a plus 1. Careful to not lose that last term, because when we distribute, we need something there so that it comes back. And that 1 is our placeholder. So then I can go 2r, 10x, 10x. And I need something that, 10 times 1, I need something that multiplies to 10 and adds to be 7, so 2 and 5s. And everything's positive, so plus 2 and plus 5. So then on this side, I need to kill off a 10 because I got an extra 10 going on. So on this side I can do a 2, on this side I can do a 5. And now I got 2r, 5x plus 1, and 2x plus 1.